And we are live. We are solving day 5 advent of code today. Let's go over the problem. Day 5, if you give a seed, a fertilizer, take the boat and find the gardener right where you were told he would be, managing a giant garden that looks more to you like a farm. Water source, island is the water source. You point out that no island isn't receiving any water. Oh, we had to stop the water because we ran out of sand to filter it with. Can't mix now with dirty water. Don't worry, I'm sure we'll get more sand soon. We only turned off the water a few days. This phase sinks into a liquid fertilization. Making sure everyone here has food that I completely forgot to check. We stopped getting more sand. There is a fairy living zone that is headed over in that direction. It's much faster than your boat. Could you please go check it out? You barely have time to agree to this request when he brings up another while you wait for the ferry. Maybe you can help us with our food production problem. The latest island almanac just arrived and we are having trouble making sense of it. Puzzle report lists all of the seeds that need to be planted. It also lists what type of soil to use with each kind of seed. What type of fertilizer to use with each kind of soil, and what type of water to use with each kind of fertilizer, and so on. Every type of seed, soil, fertilizer, and so on is identified with a number, but the numbers are used by each category. That is, soil 1 to 3 and fertilizer 1 to 3 are necessarily related to each other. For example, we have these seeds: soil to seed to soil mapping, soil to fertilizer mapping, fertilizer to water mapping, water to light, light to temperature, temperature to humidity, and so on. The almanac starts by listing which seeds need to be planted. This initial list of 4 integers. The rest of the almanac contains a list of maps which describe how to convert numbers from a source category into numbers in a destination category. That is the section that starts with X to Y map, describes how to convert a seed number to soil number, the destination. This lets the gardener and his team know which soil to use with which seeds, which water to use with which fertilizer, and so on. Rather than list every source number and its corresponding destination number one by one, the map describes entire ranges of number that can be converted. Each line within a map contains 3 numbers: the destination range start, the source range start, and the range length. Consider this example again. Seed to soil. The first line has a destination range of 50, source range start of 98, and range length of 2. This line means that the source range starts at 98, contains value 98 and 99 because 2 numbers including 98 from 98. So 98 and 99, the destination range is the same length, but it starts at 50. So its values are 50 and 51. Okay. L to L plus 2 minus 1, this, sorry, x to x plus 2 minus 1, and y plus 2 minus 1. This information, you know that seed number 98 corresponds to soil number 50, and okay, so the length of them would be same, hence there is a one-to-one mapping between the sequence of numbers from left to right. The second line means that there is a source that starts at 50 and contains 48 values from this to this, and corresponding for 52 it would be 52, 53, all the way up to count of 48. So this sequence and this sequence, and So seed number 53 corresponds to soil number 55. Why 53? 50, 51 all the way from there, and 52 there. Okay, so the first one is what? Seed to soil, right? So 53 in this list, which would be here, would map with 55 in this list. So seed to soil map, hence, but this array is the second sequence. So this is quite confusing statement overall. Seed to soil. First line is the destination. Okay, so they're given destination as the first sequence, and this is the length. Source is the second one. So this is soil. Sorry, this is seed. This is soil, and this is seed. And seed number 53 would be here, and soil number 55 would be here. So that is how this sentence makes sense. Any source numbers that aren't mapped corresponding to the same destination number. So the number 10 corresponds to 10. Any source numbers that aren't mapped correspond to the same destination number. So the entire list of seed numbers and their corresponding soil numbers looks like this. So this sequence of seed was from 50 and soil was from 52, which is listed here, 50 and then 52, and all the way of length of this third parameter is this mapping, and which was up to 97 and 99. 97, 99. Why is 98 mapped at 50? 0, 0, 48. Until 48 it's fine, until 49 it's fine, but it starts with 50 here. So the ones that were left were 50, 51, and so on. So, but this statement means that any source numbers that aren't mapped correspond to the same destination number. That aren't mapped. So 97 and 99. '79 corresponds to this number. You can look this one number record for each initial seed number. Seed number 79 corresponds to soil number 81. 55 with 57. If it lies in that range, it is +2, and if it doesn't, it is same. But for all the ranges after that, it is different. Okay, we can do that. The gardener and his team want to get started as soon as possible, so they would like to know the closest location that would succeed. So they must find the lowest location number that corresponds to any of the initial seeds. Okay. This example, the corresponding types are seed. 79 to soil, 81, 81, light temperature, humidity 78. Okay, I need to compute this. But this is just one mapping, right? So for this also it could be calculated. And I hope, okay, wait, this first sequence was taken from this, right? So these two values came from the first case. So 5051 and 1999 was this right here. It's 5051. So to soil. Why is it? Shouldn't be like 98. Yeah, it should be 98 to 51. Right. And for everything else, the mapping is 1 to 1. And once we know this mapping, we need to traverse the graph from each starting position, maybe. On this side, we go to its soil, then from that soil to its corresponding fertilizer, then from this fertilizer to its corresponding water, and so on until we reach humidity. What's the okay humidity to location? So this is what we want to reach at. And the lowest location among all of them is that is the lowest location number that corresponds to any of the initial seed number. Fine. And this is the input seeds, auto seeds, and so on. Location. Okay, fine. Let me think how we can implement this. First of all, these ranges are quite large, and even these numbers are quite huge. So we can't simply go ahead and create the mappings for all these numbers. So let's think about that. This we can convert them into ranges, and we can say that this range maps to this number. And if we are currently at some, what do they call that? If we are currently at some category number X, and that X does not belong to any of these, then it is simply passed on to the next one. And how do we find out its original mapping? And I hope these mappings don't intersect. I hope that is what they have considered in the question. Okay. Okay, let's start with the implementation. University 2023, day 5, day 5. I think the problems this year are quite difficult as compared to last year because of ChatGPT. Let's write this example first so that we check its correctness. I have this. Let's input the first line. Let's say seeds. Let's do that separately, or is it fine if I do it? Let's not clutter the main function. Take in, let's say, not a line but a word. The first word would be seeds, this thing, and after that we will keep taking words one after the other, and these are three numbers in a sequence. So what we can do here is sort. Let's take words only. Here it should be an integer first. So the count is different, so we can do should I transform the input? Is it I think the input is same, right? So how many of these mappings are given? Map 7 are given, and here also 1 2 3 4 5 6 7 are given. Okay, let's do that. I will transform the input only. Seven of these. These are the mappings. Should I do it different? I think so. And here it should be pair. So like this. No, not like that. Let me replace this with this and 2 with comma, and then this thing. These are the mappings to soil. And first this is given, then this, then this, then this, and then this. Okay, let's also transform the input. For now, let's say I also have the count for all of them. So 2 of these, 3 of these, 4 of these, 2 of these, 3 of these, 2 and 2 again. And this count is 4. It's very easy to do this way. First we take the count, and for this, those many number of times we take the seed value. We add it in the seeds. Then for each of these pairings, so from 2 in pairings, we take the count of them, and for those many number of times we take in 3 integers. The first one was destination and source and length. Let's say destination, source, length, and let's store them somewhere. Mappings. We need a vector of let's store it in an array of length 3. What do we need here? Let's store them ranges, and we need 7 of these since this is 7. For each of those mapping, we will store these corresponding ranges in that ID. So index ID is 0 initially, ID plus equals to 1, and ranges of that ID dot push back destination source length. This should be the parsing of input. Then for each of these seeds, we will go over this, right? Seed in let's say the starting position is X and it is seeds. For each of them we will let's say what is the mapping index we are currently at. Initially it would be 0. We need to go over seven of them, and to do that I don't think we even need these values because we are not passing them anymore. And now since we have these ranges in this particular order in which they are given in the input, we can simply go over these ranges of this particular mapping ID. So for was destination source length, destination source length in ranges of this mapping ID. Now we know that SRC is mapped to destination, SRC plus 1 is mapped to destination plus 1, all the way up to SRC plus length is mapped to destination plus length. I hope that is correct. So 98 seed with 50 soil. 98 seed with 50 soil, and it should be -1 because they are considered if it is 2 then it would have been 100 to 52, but that is not the case. So here it should be all the way up to length -1. Fine. Now we check whether so if there is a mapping possible, then X belongs to this range. X belongs to SRC to SRC plus length -1. And in that case we can simply derive what should be the next thing that it should change to. So if SRC is less than equals to X and X is less than equals to SRC plus length -1, then X is now destination plus. Okay, we also need to know what is that particular thing, right? Difference would be X minus SRC, and the value for X now changes to destination plus difference. Let's see. So if X was, let's say, in this case only, right? Where was it? Okay, 79 is soil number 81, and in this table let's not take 79 but something else, maybe 55, 13 is the 13, but 79. And if we were given 79 lies in this, so 79 minus 50 would be 29, and 29 plus 52 would be 79. That's wrong. I think we figured out that if this lies in any of these ranges, it becomes plus the length amount, right? Not. destination. What was the example? Is right. Here, let's say x was 79, right? X was 79. Then diff would be here. We have destination, source, and length. Diff would be 79 minus source, which is 98, which would not be considered in this one. So let's say this is ignored. It would be considered in this. So 79 minus 50, 29, and now we are assigning it to 52 plus 29, which is 81. Hope that's correct. Okay, let's move on with this. If we don't find anything, that means x remains as it is, so there is nothing to consider in that case. Let's check it. Let's just seed, and x is seed. So now let's say we check what we currently arrive at. Have they given for each of them? Should I check intermediate results? Answer is minimum plus x. Answer is 35. In the first case, we get 81, which is wrong. And we get 14, 81, 14, 57, and 13. These are all correct in their respective iteration, but aren't we doing it again? Okay, mapping ID, I did not increase. Okay, there is no need of mapping ID. We need to do it for each of them. So mapping ID in this range. Right. $82, $43. No. $86.35 is correct, but this is not correct. 32. Let's check intermediate results. This looks correct for seed 14, 53, 53, then it became 38 somehow. Let me check the input once again. Should be fine, I guess. Input mappings. This mapping is not needed actually. We can simply do IT in this range. We take the count, input numbers those many number of times and add it in this. We don't need this. I hope that they have given this input which is valid. Rather than list every source of x is in this range. Second case was circuiting wrong. Is it 43 now? Or okay, fine. Looks correct now. Okay. Maybe what it did was, let's say there were a lot of ranges. In the first range, it updated the x, right? So in the first, let's say for some range, it updated this, but we were not breaking out of this mapping, current mapping. Hence, it is a possibility that in the same mapping we find another range which satisfied this condition, and that's why it would have given us a wrong answer. I also need to change the actual input. Okay. How many of these? 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18, 19, 20. Let's see, this to this is 28 lines. I can see in the bottom right corner. This to this 28. 10 lines, 9 lines, 23 lines, 32 lines, 45, 49, and I hope there are 7 of these. Let's see. 1, 2, 3, 4, 5, 6, 7, and initial input. Okay, looks cool. Let's try it. Let's check this one. Okay, perfect. Let's move on to part 2. Everyone will starve if you only plant such a small number of seeds. Reading the almanac, it look like the seeds actual line actually describes ranges of seed numbers, the value on the initial seeds line coming pair. In each pair, the first value is the start of the range, and the second one is the length of the range. So in the first line of the example above, this line describes two ranges of seed numbers to be planted in the garden. The first range starts with seed number 79, contains 14 values. 14 values from 79, including 79. The second range started with 55. Okay, fine. Now, rather than considering four seed numbers, you need to consider a total of 27, which is 39 plus this. A total of 27 seed numbers. In the example about the lowest location number that can be obtained from seed number 82, which corresponds to soil 84. Come in pair, and I hope this length is even so that the pairs complete. So in this example they are given 4, and in this example they have given 20, as we found out. So for 27 of them, right, so this one and this one, we'll find out the same algorithm by applying seed equals to that value in that particular range. You need to consider 27 seed numbers. In the above example, the lowest location number that can be obtained from seed number 82, which would lie somewhere here, corresponds to soil number this cemetery location 46. So the lowest location is 46. Considering all of the initial seed numbers listed in the ranges on the first line of the almanac, what is the lowest location number that can correspond to any of the initial seed numbers? Okay, I understood what we need to do, but the thing is, these values are fairly large, so that may take quite a while. If you notice, this is up to 10 raised to 8. Right, we can apply that and check what will be the answer. Let's try it. If it is not working, then we can optimize it always, because premature optimization is the root cause of all evil. We will check that length of seats is even. Then we will through all of them. IDX is now seed is seeds of IDX and what was it? Let's start and total is it's of IDX plus 1. And one more thing, what was the range values? 79 plus 14. 79 plus 14 minus 1. Okay. This loop should go for x. Let's just seed from start to start plus total minus 1. And in that, we need to consider x equals to seed and perform the operation. And I can also memorize the answers. Let's see what I can do. So we cover the sequence of seeds. It is not a sequence of seeds now, but a sequence of numbers where the first pair is the starting and this is the count. Then we need to initialize seed with in this range start to start plus total minus 1. Access this seed now and we perform the same operation again. Let me delete this for now. Now if a fixed x, let's see if we have already found out the answer for this. Cache. I think it would be a fairly large cache. Cache.count x return, and it doesn't matter what seed you start at, the answer is always cacheable because we simply traverse the path from one range to other. And even I don't think this would make it slightly better or something, because this is hardly 7 times this range lengths overall to around 100 or something. But let's try it anyways. Okay, it works on the sample case. Let's try. It would be very slow though. I don't think this is the intended solution. One thing that I can do is, there are limited number of seed to soil mappings, and we are iterating over seeds which are very large, or what I can say, which have large ranges. So somehow I need to get rid of this loop. To do that, instead of iterating over all the seeds, so this first iteration would go from seed to soil, right? Yeah, seed to soil, and there are still there are a lot of processes to consider. Seed to soil. Hmm. I'll try to find some optimization or any observations in this question if there are possible. Let's see what our slow solution does. We fix some seed value initially. Let's say that is seed value, and then we start with the zero mapping. So let's say here I'm writing mapping ID 0, 1, 2, 3 all the way up to 6. This value initially is x, and there are some ranges for each of them, right? So L1, R1, R2, R2, and LK, RK. Now this x can lie in any one of this, right? X belongs to this range. Now, if it belongs to that range, we'll select it and make it equals to whatever value that was possible, right? Now x becomes something else. From there, let's choose this range, then something else, and so on. And at the end, we arrive at the location